So in this second video, we're going to discuss how to approach assignment 4, starting with part 1A. So in part 1A, what you need to do is you want to write an assembly program, a word counting program in assembly language. If you read through this, you will understand what word counting means. You're going to be counting lines and characters and words in different files. So try to understand this. This is very similar to the Unix WC command. So basically what you need to do is to convert a program that's given to you. The program is called mywc.c. So that's what you have. So this is what mywc.c looks like. Got some includes, some enums, some static things. Some of them are initialized. And then you got a bunch of while loops and if statements and increments and all that, and a printf statements at the end. So the key thing here is to learn how to convert enum, how to convert this, how to convert things that are equal to 0 and things are not equal to 0. How do you deal with the types? And then how do you deal with functions like get character? How do you deal with while loops? How do you deal with increments? And so on. So the clean thing is that we want to take the C program and create something that is going to be good. So what's the process? So the process is going to be, we're trying to understand how to go from C to assembly. So, we're going to show you a method where you can take any C code and you can convert it to a format called Flattened C code. And then from there, it looks very much like assembly. So you're less likely to make mistakes converting from C to assembly if you go through Flatten C. Now, clearly, we can use the GCC command with the -s flag to convert C code to assembly code directly, but that's not what you're supposed to do. In fact, if you do that, your code, and it's going to be quite different from a code that's produced by a compiler, and we don't want the compiler code. So you'll have to write things from scratch. That's the goal of this assignment. So what is Flatten C? That's an interesting idea. So we go and look at what Flatten C is. You have a handout on that, or you can go to Salon. So the idea is if you have a statement such as this, which is very familiar to you, in C, how do we convert that to something that has this special thing called goto? Now, goto is something you haven't seen before, but it does exist in the C language. So it's more like a jump in assembly. So the way we deal with this, we convert this to Flatten C, is to look at the negation of the expression. So if it's not the expression, then we must go to the end of it. So we have a loop label called end if. So we go to that. Otherwise, you're going to do statement 1, statement 2, up to statement n, and then we have to do something. In this case, there's nothing below this, so we didn't have to worry about it. So here's a bit of a complicated one. So you have an else statement here. So in this case, you do the same thing. You look at the negation. If it's not the expression, go to else. So there's a label called else. And then we do statement T1 through whatever, Tn. And then after you do that, if you do these statements, you don't want to do these statements. So therefore you have go to end if, which is this one here. So from here to here, you make a jump. While expression. This is a familiar while expression in C. In the while expression, what we do is we check the expression. But in this case, we're going to check the negation of the expression and then go to the end loop if it's true. Otherwise, you're going to do these things. So that's the goal. So what we're going to do is to demonstrate to you a simple C code that's converted to the Flatten C code and then converted to the assembly code and how that looks like. Okay, so to start with, let's look at two programs side by side. And one is given in C code and the other one is given in Flatten C code. So the question is, how do we go from here to here? Now I made it quite easy or quite simple, but it does have the things that you're looking for, because in your case, what you're looking to do is to convert this program. It does have enums, it does have these things. But so what we're going to do is to understand something simpler, and then hopefully we'll learn how to convert what you have to do. So in this case, I have a defined max count to be 50, just some constant text replacement. I have two static integers. They are not initialized. And then I have a main program where the sum low is initialized 0, sum high is initialized 0, and then you're running a loop from count to the max count. If the I count is less than the max count over 2, which is like the half of it. So if you're on the lower half, I'm going to sum the I count into the lower half. Otherwise, I'm going to sum the I count into the upper half. In other words, you can think of something like you have something from I to max count, 0 max count, and anything below 25 I put into one thing, and anything above 25 greater than or equal to 25 I'm going to put the other things, right? Then once I do that, I'm going to look at the count. So this would probably produce something called 0 to 24, and then perhaps from 25 to 50. So that's what we're looking for. So now we got to learn how to convert this to Flattened C code. Now this is side by side. Nothing has changed as far as these things are concerned. They are still the same. The main program is the same. These two are the same. Now there are some differences coming. Now we have to understand the semantics of the for loop. In the for loop, we say I count equals 0. So we're going to do the I count equals 0 first. So that's what this for loop does. The second thing for loop does is to compare the I count to max count. But remember, in going from C to Flatten C, we're going to look at the negation. So in this case, I'm going to say, what if I count is greater than or equal to max count? If that's the case, then I'm done. So that means I'm going to go to the end of the loop right here. So notice the loop end is right here. This means I'm going to be doing these statements. This one's going to do that, those statements. So now, once I get into the loop, suppose that's not true. So we get to the loop, we have another conditional statement. So in that case, I have to compare I count. I'm going to look at the negation again. I count greater than or equal to max count over 2. If it's true, then I need to go here. So that means I will go to if else, right? If it's not true, then I have to increment the I sum low by I count. But if I do that, then I won't do the this part here. So therefore, I go to the if end. At the if end, I have to do the following, because that's the end of the loop right here. So before you go back to the loop, if you go back to the beginning of the loop, I need to increment the I count by 1 and then go back to the beginning of the loop. So this is hopefully this code, and this code will produce the same output. So let's take a look at that. So are they producing the same outputs? This is the first thing you've got to check. Once you convert 1B, part A, you have to convert your C program into a Flattened C code where you have no loops. The only thing you have is go to and go to statements, and then some labels. Those are the two things that you have to introduce into your C code. The question is, are they producing the same output? So let's take a look at that. So I'm going to open up this window here. So here's what I'm going to do. I'm going to say GCC 217, and this program is called the C2 assembly. So that's, I'm going to take that, and then I'm going to put that into an object called C2A. And then this program is called Flatten C2 assembly. So I'm going to do the following. I'm going to say, okay, let's do the following. Flatten C2 assembly C, and then I'm going to put this object code in the F C2 assembly. So I have two object files now. One C2 assembly, which is produced by this, and the other one is Flatten C2 assembly, which is produced by this. Now, if I did the conversion correctly, they both should produce the same output. That's the first thing you need to do in your assignment. Just make sure once you convert this to Flatten C, you run them and see if you're going to get the same thing. All right, so I'm going to run this, first of all, C2A, which is the output from this program. So I get 309.25. Then I'm going to run this one here, which is the output from this program. So that's called Flatten C to A. I get the same thing. So if you like, you can make some changes, see if still the same, but most likely, if you did correctly, then it'll be the same. So now we're going to learn how to go from Flatten C to the assembly. So let's compare the program on the left-hand side and the program on the right-hand side. The program on the left-hand side is the Flatten C code we just executed. We know what the output is supposed to be. And we want to do an accurate transformation of this code into the assembly code. So let's take a look at some of these things. Obviously, I'm ignoring all the comments that you should be making. I'm going to start from here. Define max count is 50. So this means that it's a text replacement. I replace that line with this line here, dot equal max count comma 50. Again, that's going to replace max count by 50. Then I have something called section row data. Now what I put in that thing are the two strings that I need for the printf statement later on. I give them lows, a label C low and C high. I have the data section, but I'm not putting anything there because I'm not really initializing any of these global variables. Then I have three global variables, static, which are here. I'm going to put them in this section BSS. Because they're both, all three are integers, I'm just going to call them the same label name. I'm going to skip 4 for all three labels here. So I'm converting this to this. So let's move on to the next section. So in the next section, I have the main. So I want to have the global main, which is very important, and I have the label main. So I'm going to transfer these, convert these three lines of code into assembly code. So essentially what I need to do is to move the immediate 0 into all these variables, isum low, isum high, and icount. So that takes care of these three lines. Now I have the loop begin, and I have to convert this line into the assembly code. In order to do that, what I need to do is I need to have something max count in one register and icount in another register. It's important to have them in registers because we're going to be comparing registers. So what I'm going to do is I'm going to move the max count to the EDI register. Now you may recognize that EDI I have used in other places, but let's move it to EDI. You can choose anything you want right now. Okay. In this case, there are a bunch of other registers that you could have chosen. So I move the max count into EDI. I move the I count into ESI. So ESI contains the I count. I'm checking whether I count is greater than or equal to max count. So I'm going to compare ESI. So I'm always comparing ESI to EDI. ESI contains I count. This contains max count. So if ESI is greater than or equal to EDI, which means I count is greater than or equal to max count, I say go to the loop N1, which is the same as this one here. All right, and then let's go to the next line. So here's the next line. That is very, very similar to the other one, except we have to divide by 2. So what do I need to do? First of all, I'm going to move the max count into EDI. EDI contains max count. Now, but I don't need max count. I need max count over 2. So what I'm going to do is I'm going to do shift arithmetic right L, which is because I'm using for 32-bit registers. So EDI, so this means I'm going to shift EDI, which is max count, which is really 50, by right by 1. This means you're dividing by 2. Then I'm going to move the I count into ESI. And I'm going to do the same comparison I did before. I'm comparing I count to max count over 2. Jump on greater than or equal to, I'm going to go to if else. So next line is this one here. Okay, how do we do that? So that's what we are showing here. So in order to do that, what I need to do is I have to move isum low to some register. Let's move it to EDI. And then I want to add I count to that register. This means now EDI gets the old EDI, which is isum low, plus the I count. That's what this means, right? Isum low equals isum low plus I count. Once I do that, I want to save the register content in the isum low. That's my variable. And I say go to if end. That's the same as a simple unconditional jump. So I do that. Let's move on to the next few lines. So go to event. Now we are here. ISOM high equals plus count. It's the same thing. I'm going to move the I count into ESI. That's the 1 second here. Yeah, this one here. So we're looking at this. This is the same as that one. So we're looking at ISOM high plus equals I count. So what we're going to do, right? So move the ISOM high to EDI, add the I count to EDI. So now EDI contains the sum ISOM high plus I count. Move that EDI to ISOM high, which is what this does. Now I want to increment the I count. To increment anything, you have to move the memory value to the register, ESI. I'm going to increment the register, then I'm going to take the register and put it back in the I count. You might be able to make some efficient operations here rather than moving things around all the time. But I didn't really pay much attention to that. I'm going to leave it to you if you want to do it. Then go to loop begin means just jump and do an unconditional jump to the loop begin. The other two are really printf statements that we have seen in the precepts and other places. So this is exactly what you have here. So now the question is the output from this one will be equal to the output from this one. So let's take a look at that. So what I'm going to do is I'm going to say, okay, so I know the output from this one, it was called FCTA. So if I do FCTA, I get 300 and 205. Now, if I do Flatten C, so for example, if I do GCC 217 Flatten C, and this is this S code I wrote, this is the assembly code I wrote, and then I write it to, let's write this object file into, let's call it flat assembly or something. Okay, flat assembly, doesn't matter what you call it. And then I'm going to run the flat assembly executable. If I did it correctly, the transformation from here to here, I should have gotten the same output. So if I do that, notice I get the same output. Now, what if you don't get the same output? What you can do is to really do this. You can really go to, well, I didn't do the correct thing here. Let me just compile this for debugging. I'm going to start Emacs, and then I'm going to say, okay, let's go to the debugger and GDB flat. Okay, so I'm going to put a breakpoint at 1 and then start running. So here you start running. So if you go next, you can see the things are moving, At this point, maybe you want to look at registers. So if things are not working, you want to look at the registers, right? The question is, how do you look at the registers? So there's a GDB command called info registers. So I'm going to say info registers. So I'm going to call it IR. Okay, info registers. And let's look at EDI. What's in EDI? Well, EDI is 50. So I think as expected, it was 50 here. I moved to the EDI. What if you look at ESI? ESI should be I count should be 0. Let's see whether that's the case. Yeah, it is 0. So if you keep going, you're going to this here. Now this is an interesting one to look at. Now I took the max count, I shift arithmetic right by 1, and now it's in the EDI. So let's take a look at information register EDI. And it turns out to be 25, which is good, right? So it's working. It's working the shift arithmetic, which is going to give us the division. So in terms of debugging the assembly code, what you need to do is to really do the same thing, except that you have this special command that you can still print things like that. You can say print I count, which will show you the value of the I count at any point. So if you're really having trouble doing the program, getting the right output, you may want to debug the code using GDB. So you can probably figure out where it's going to fail. It's not going to give you the right output. So the only new thing here is that the IR, which is the info register EDI, show me the information in the register EDI. So you can look at the inside the registers in any case. So we'll do another video for the part 2. Good luck.